Good morning, student. Today we will do another experiment on VLSI lab. The aim of the experiment is design and implementation of full adder. Equipment required is Xilinx IAC software and a personal computer. First, we discuss the theory part of this experiment. So, the full adder is a 3 input and 2 output combinational circuit. So, in this schematic, you can see at the input side 3 inputs are given, and at the output side we get 2 output. So, the sum S is equal to A XOR B XOR C. Okay, and the carry C equal to AB plus BC plus CA. So here the input is written as C in. So in place of C, just we have to write C in. Next is the circuit diagram and truth table. So here the circuit diagram is as per our equation, that AB denoted using an AND gate, then AC using AND gate, BC using AND gate, then AB plus BC plus CA. So 3 terms are combined using a OR gate, and here a XOR gate is used to give the output of sum. And this one is the truth table. Truth table, here as we have 3 input, because of that we have 8 combinations of input, and at the output also we get 8 different outputs. So when the combination of input is 0 0 0, we get a sum that is 0 and carry 0, and when the combination of input is 0 0 1, then we get 1 and 0. When the combination is 0 1 0, at the output we get 1 0. When the combination is 0 1 1, at the output we get 0 1. And when the combination is 1 0 0, then at the output we get 1 and 0. Then when the input is 1 0 1, output is 0 1. When the input is 1 1 0, then the output is 0 1. Last combination is 1 1 1, and the output we get 1 1. Means at the output for sum we use the equation A XOR B XOR C in for find out the output using the input combinations, and for carry we use the equation AB plus BC plus CA. Using the value of inputs we get our output. So this is all about the theory part of full adder. Let's do the experiment. For experiment, first we have to open the software. Click on this icon, then this window will appear. Then first we go to the file and create a new project. Next, then finish. After the creation of the project, we add a new source. Then this window will appear, and in this window we select VHDL module. So today we will do the experiment of full adder. For that we give the name full adder. Then next, here we give the input and output. So as we know, a full adder has 3 input, so ABC, and 2 output, that is sum and carry. And here we change it from in to out, that represent output. Then next, then finish. Then this part will appear, but this is not the complete programming. We have to declare the functionality of full adder, that is sum, assignment operator, A XOR B XOR C, then carry, assignment operator A and B, bracket start, A and B means AB. Then what is the equation? AB plus BC plus CA. So A and B, or bracket start B and C bracket close, or bracket start C and A. Okay, then click on this implementation and check syntax. Here you can see a green tick, that means this programming has no error. Then we see the RTL schematic. Then click on OK. This one is the schematic having 3 input and 2 output. Okay, and this one is the internal diagram having 3 AND gate and 2 XOR gate as per our equation. Okay, then we go to the simulation part. Then again add a new source. Before that I close it. New source. Here in this window we select VHDL test bench and give the name full adder underscore TB. Then next, finish. Then we just replace the programming, as we have to change a lot in this program, so we just from here we select the test branch program and paste it. Then check behavioral syntax. Here you can see the green tick, that means there is no error present in this program. Then we simulate behavioral model. This one is the waveform. Here is the yellow pointer. We move this pointer to any point and see the or compare the input and output. So right now at this point the input is A is 1, B is 1 and C is 0. So for sum we do the XOR operation. So here you can see we get a 0, and for carry we do the operation on the equation, that is AB plus BC plus CA. So after that we get a 1 output. Let's check at another point. Here ABC, that is 1 0 0. So sum is 1 and carry is 0. So our programming is properly working. So here is the programming. Let's discuss about the programming. This one is the library part that include the library and import the necessary packages. Then the entity, here we define the input and output ports, and here our design have 2 input bit and 2 output bits, 3 input bits and 2 output bits. Then this one is the architecture part. In the architecture we define functionality, and here in the test bench programming, first is the library part. We know that it include the library. Then entity, here we define a blank entity as a test bench does not define actual hardware. Then this architecture part up to this. So here we declare component and signal in its architecture. Then here unit under test, here we just port map the internal signals and ports to enable the test bench to inject input and read its output. Then the last part, that is the STIM process. So inside it we inject values to the inputs and wait for some time. Means to properly observe the output we give some delay, that wait for 20 nanosecond. That may vary as per the requirement. Okay, so this is all about full adder. Thank you.